Anyways, let's talk about the main thing, which is how to do this experiment. So let's dive into the procedure. Firstly, you have to check the reactor whether it is empty or not. And if there is any previous water batch, you have to drain it out. How will you drain it out? So there is a wall provided below this reactor, and you have to just open this wall so that all the water will flow down the reactor and the reactor will become empty. And after uh, doing this process, you have to make sure that you close the wall so that when you are pumping out the water in the reactor, there is no flowing down water. Now, after closing the wall, fill the reactor with the feed tank with water. So from this tank, which is in water here, and from this tank, water will flow down the reactor, and you have to make sure, I'm repeating this again, that the wall is closed. And after closing the wall, we have to switch on the main supply, which is from the switchboard. And from then after switching on the main supply from the switchboard, you have to turn on the agitator and the pump.
Adarsh, this isn't the pump. This is the pump.
Sorry.
Anyways,
Yes.
let's move on with the procedure further. We need to adjust the flow rate using the rotameter at different flow rates and let it flow through the CSTR and let it achieve the steady state. Meanwhile, let's move to the center part where we have a burette. We need to fill the burette with 0.1 normal NaOH for the titration with the help of when it flows on the CSTR. Once the steady state is achieved, we need to add tracer using 10 ml syringe which has glacial acetic acid. The syringe is pumped into the CSTR and it gets flow from the outlet pipe. We collect the sample in the 250 ml conical flask and move it to the burette where we have 0.1 normal NaOH. We add 1 to 3 drops of phenolphthalein to get the titration endpoint. Once we add phenolphthalein, we titrate it using 0.1 normal NaOH. We titrate it till we get a light pink color, which is the endpoint for the acid and base reaction. With this, we conclude one set of reading. Now note down your reading in your observation book and move on to the next set of collection of the sample. After every 2 minutes of steady state, collect 15 more samples, and with this we conclude the titration. Now let's move on to the closing procedure.
Thank you, Yash. So now we will talk about the closing procedure. So after you have done your experiment, you have to close this pump. This is the switch off pump. You guys remember it? And now after switching off the pump, switch off the mains from power supply. And after doing switching off all the things, make sure that you drain the water from the reactor using this wall. So this is the wall. You have to drain the water from that.
So now I will show you a sample titration. I have collected a sample here now and I filled NaOH in this burette and added 10 ml HCl in this. Now we are going to titrate it. See. You need to always keep stirring the conical flask so that the NaOH is evenly mixed with the content in the flask. Keep mixing till you see a color change. Keep stirring, keep stirring. See, I can see a color change. Can you all see it? A pink tint is getting generated. And you keep adding one more drops till you see a stark change in the color. And then note down the readings. What is, you can see 27 ml.
So today we are going to see the calculation part of RTD studies in CSTR. So first, let's just mention the known values in the RTD studies of CSTR. So known values is, first of all, the volume of reactor, which is 2.88 liters. Next, the volume of sample we are going to take is 10 ml. Also, the normality of NaOH would be 0.1. Now let's just start with the calculation part. So let's just take the observation. So we have taken the observation of two flow rates. First is 10 lph and second one is 20 lph. In every interval of 2 minutes, we have collected the sample of 10 ml and then we have titrated it and found the volume of NOH for every 2 minutes of interval, which is as mentioned over here 16.4, 5.6, 4.9, 4.1 and all till 28 minutes. And in 20 lph we have taken till 22 minutes. Now let's just take the observation of 20 lph. Let me just make it big. Okay, good. Now let's start with our calculation. First, N1 V1 is equals to N2 V2. N1 V1 are the values of the sample that we have collected, and N2 N2 are for the NOH part. Now let's just take the observation. First observation for 0 minute, the volume of NOH is found out to be 1 ml. So we have to find the concentration of the sample N1, and we know the volume of sample we have taken, which is 10 ml, and we also know the concentration of NOH, which is 0.1, and from the observation we also know the volume of NOH, which is equals to 1. So the concentration of the sample we found out to be 0.1 into 1 divided by 10, which is equals to 8, which is equals to 0.001. 8. It's actually 0.0. Sorry. As mentioned, similarly for every observation, we have to do the same thing. N1 V1 equals to N2 V2, and find the concentrations till 22 minutes. Next, the value of CT. CT is just the multiplication of concentration with time, C into T, for every observation, like 0. For first observation, 0 into 0.01, which is equals to 0, 0. Similarly for every other observations. Next, for E, formula for E is equals to C upon summation of CT. Now let's just take the summation of CT value, which comes out to be summation of CT from the observation table is equals to 1.216. So for every C value, we have to divide it by summation of CT, which is 1.216. Like, let's just take the first C value, which is 0.01. So 0.01 divided by 1.216, which comes out to be 0.00822. For every observation, we have to calculate the E value from this given formula. Just change the value of C and divide it by 1.216. Now next we have to calculate the value of E delta T. E delta t. We have already calculated the value of E for each observations. Now delta t. Delta t here also is the constant value, as the time difference we have taken as the time difference we have taken is 2 minutes for every interval. So delta t will be constant, which is 2 minutes. Let's just take the example for the first observation. Like we have E for the first observation is 0.00822, and the time difference would be 2 minus 0, which is equal to 2 minutes. So V delta t would be for first observation 0.00822 into 2, which is equal to 0.01644. 0.01644. Now let's just go to the next part, which is F. F, we know that F is the summation of E delta t. Now let's go through with the observation over here. So the first value of our observation is E delta t. Wait, let me just erase the things. Summation of E delta t for the first observation is 0.01644. It is same as 0.01644. For the second observation, it would be 0.01644 plus 0.0806, which is equal to 0.097. Similarly, for the third observation, our F value would be 0.01644 plus 0.0806 plus 0.592, which is equals to 0.1562, 0.1562, and so on. So just add on these E delta t values and you will get the values of F, as F is equals to summation of E delta t. Next, we have to calculate the t square. For this t square values will be useful for the next calculations of model. So just square it the values of time, which is 0, 0 square 0, 2 square 4, 4 square 16, 6 square 36, and so on. Next, we have to calculate the value of t square c. Just as we have already calculated for the value of t square and the concentration, just multiply it and get the observation. As mentioned over here, these values are already been calculated. The further needed informations are, wait, let me just erase these things. Further needed informations are summation of C, summation of CT, and summation of T square C. From the above calculated values in the table, we can get the values of summation of C, which would come out to be 0.19, and next summation of CT would be 1.216, and summation of T square C we found out to be 12.504. Now we are going to calculate the mean residence time value. Mean residence time is denoted by T bar, which is equals to summation of CT upon my summation of C. We have already calculated the values of summation of CT and summation of C. So the summation of CT is equals to 1.126 upon 0.19, which comes out to be 6.4 minutes. So the value of mean residence time is 6.4 minutes. Now next we are going to calculate the variance. The formula for the variance we have already seen in the theory part, which is equals to summation of t square c by summation of c minus residence time square, which is equals to 12.504 upon 0.19 minus 6.4 square, which comes out to be 24.85 minutes square. Next, we have to calculate the dimensionless value for the variance. The formula for this is variance square upon mean residence time square, which is equals to 24.8485 upon 6.4 square. We have already calculated the values of variance and the mean residence times. So dimensionless value comes out to be 0.6067. Now, as we have calculated the dimensionless value for the variance, we have to calculate our final result, which is dispersion number, which is equal to d by ul, which is equals to sigma theta square divided by 2. And we have already calculated the sigma square theta, which is 0.6067 by 2, which comes out to be d by ul is equals to 0.3033. This is our final result. This value we have calculated theoretically by several observations, and this one is for the flow rate of 20 lph. Similarly, we have to calculate it for 10 lph. We have already calculated it for 10 lph values for several observations. This is for 20 lph, and for 10 lph d by ul is found out to be 0.5378 for 10 lph. Similar type of calculation is followed for the 10 lph value.